Hello students. So today we'll discuss one chemical reaction which can be used as a test for the detection of aldehydes and ketones. And that one is, it is addition of sodium bisulfite. Or we can say this one is sodium bisulfite test for detection of the carbonyl group, means for detection of aldehydes and ketones. Here what happens, aldehydes and ketones when treated with sodium bisulfite, so they gives sodium bisulfite adduct, and this one is a white crystalline solid. See, so what happens when aldehydes and ketones are treated with the sodium bisulfite? We obtains a white crystalline solid, and it is a sodium bisulfite due to the formation of sodium bisulfite adduct. So the compound which gives the white crystalline or white precipitate on adding the NaHSO3, so it means these compounds are having the aldehydic or ketonic group. Now what chemical change occurs here? We'll see it. See, let our aldehyde is CS3CH double bond O, and when it is treated with NaHSO3, see, the reaction is example of, it is an example of nucleophilic addition reaction. See, we know that the aldehydes and ketones usually undergoes nucleophilic addition reaction, and the reason is already explained in the separate video, that why the aldehydes and ketones undergoes nucleophilic addition reaction. See what happens here. This sodium bisulfite dissociates and forms the Na plus ion and bisulfite ion. Here the pi electrons shifted over the oxygen, as already carbonyl group is having a polarity. So here the oxygen remains partial negative charged while carbon B remains positive charged. Now the nucleophile attacks first here. Basically the structure of NaHSO3 is, see, this is the sulfur, and here it is O, OH, and here it is O and Na. Na is having positive. This is the structure of NaHSO3, and here sulfur is having a lone pair. So what happens here, the making use of the lone pair of the sulfur, this SO3H attacks first to the carbonyl carbon, because the carbonyl carbon is more reactive center in comparison to the oxygen. That's why attacks, nucleophile will attack first here, and then here you will get what, CS3CH, and here SO3H will form bond to the carbonyl carbon, and now single bond will remain here in between the carbon and oxygen. Oxygen will become now negatively charged, so the Na plus ion sets free from the sodium bisulfite, will form bond with it. See, we'll get this type of product. Now here in order to get the more stable anion, proton transfer occurs. Means this proton exchanges its position with the sodium ion here, and we will get CH3CH. Here now this Na plus ion will be exchanged by the proton, and here we will get SO3 Na. This product is known as sodium bisulfite adduct. And which one is a white crystalline solid. Is it clear? See, here why the proton exchange occurs. In order to understand this one, let this structure, which is obtained by the addition of sodium bisulfite, let it is first structure and this one is second. Now we'll compare, draw the structures of the anions obtained from the structure first and second. See here, from structure first, the anion, or you can say that this compound first will split up and will form this anion and Na plus ion. Here from structure second, the anion obtains is CH3CH OH, and here it is and Na plus ion. See, if we will compare the relative stability of the anions, these two anions, so this anion is found more stable. So in order to obtain the more stable anion, here proton transfer come into the existence. Is it clear? Now remember here, see here also means when this and in NaHSO3, the sulfur attacks using its lone pair to the carbonyl carbon. Is it clear? Now remember one thing. See, this one is also important here. Among aromatic aldehydes and ketones. See, this one is what? It is benzaldehyde. Okay, this gives the sodium bisulfite test. But remember here, if it is acetophenone, so acetophenone will not give a sodium bisulfite test. Why? See, here at the carbonyl carbon there is a CH3 and phenyl group. Phenyl group is bulky group. The CH3 is also a bulky group. And as we know, the carbonyl compounds undergoes nucleophilic addition, means nucleophile has to attack first. So already two bulky groups are here. So they will hinder the attack of the nucleophile HSO3 minus, and that's why will not acetophenone does not give the sodium bisulfite test. Similarly, benzophenone, like if it is this one, this is benzophenone. So this is not also going to give the positive silver sodium bisulfite test. Again, because there are two bulky groups linked over the carbonyl carbon, and that's why they will hinder the attack of the nucleophile over the carbonyl carbon. So see, remember that acetophenone, benzophenone, they does not give this test. Why? It is, this one is due to steric hindrance of bulky groups present over carbonyl carbon. So due to the presence of these bulky groups, so these bulky groups will hinder the attack of the nucleophile over the carbonyl carbon. Yes, one thing more here. Even ethyl ketone, ethyl diethyl ketone also does not give this test. See, diethyl ketone, this is among the aliphatic ketones also. See, this one is CH3, CH2, C double bond O, and CH2, CH3. See, here there are the two bulky groups. So they will hinder the attack of, or they will hinder the attack of the carbonyl nucleophile over this carbonyl carbon. That's why this one also does not give the positive sodium bisulfite test. Is it clear?